discussion on ray optics, and hopefully this will be the last lecture of ray optics. So, lecture number 18. Last time we started with prism, na?
Yes.
We started with prism, and then we talked about the angle of minimum deviation and the no emergence condition. We talked about those things, and then there was one more thing that is actually very interesting about prism: the idea of dispersion. So we'll talk about that today, and then probably 4 or 5 problems. And then that will be the end of the class. So let's start with dispersion. Dispersion. And when I say dispersion, what do you mean by that?
Scattering.
Not scattering, but rather splitting of light into its constituent colors. No? So if you have, let's say, and why does it happen? So if you have a prism and let's say a ray of light comes, what happens? That it splits into its constituent colors. But why does it happen so? It happens because each color suffers different deviation. If you remember, what was the definition of mu? What was the definition of mu? That's C by B. And equally I used to write lambda by lambda naught. You remember this? So, given a wavelength, your mu changes, no? Yes? So, for different wavelengths, that's different colors, you will get different mu's. And then, what was the definition of delta for small angles? What was delta for small angles? You remember? It was something like mu minus a 1 into a. I gave this formula right last time. So if your lambda changes, your mu changes. If your mu changes, your delta changes. That means different colors will suffer different deviations. That's why you get this spectrum. By spectrum, I mean the ray or the color that you get with your, you know?
Yes.
Because each color suffers different deviation. Then you find different colors. Something like yellow. Maybe there will be a red color. Maybe there is a violet color. What are violet and red, by the way? They are the extremes, na? With your B से start होता है, R से end होता है. Yes? These are the extremes. So why does it happen so? Because each color suffers different deviation. Now let me write some English statements. We will come back to all of it later. So let me erase this. And then the splitting, you should write with me. The splitting of light when it passes, splitting of light into its constituent colors is called dispersion. And just what I told you just now, what is dispersion basically? What is dispersion basically? It's that each color suffers different deviation. Arises because each color is stupid. Suffers different deviation. Is it all okay?
Yes.
Yes. Achha, when we talk about dispersion, there are two main important things are dispersion and deviation. Please don't get confused between the two things. They are two different things. Now, I will talk about 2-3 terminologies which are very important in dispersion. One of them is called the average deviation. Average deviation. Achha, let me make a diagram and then let me talk. Let's see you have a prism and the ray of light is coming like this. There can be a red color as well, huh? Yes. And how will they come out? Again, this is not actually that good. Then they come out like this. Is it okay? They come out like this, and they will see the video and those things. Okay? If you were to talk about deviations, then how do you find deviations? This is the extension of the incident ray. The extension of what will be the deviation for the yellow color? How will I define it? That's this, or rather, that's actually that. That's delta white, delta yellow. Yes. What about for red? That will be this, delta R, and this will be delta B, delta white. In Vibgyor, what is the color which actually lies somewhere in between? We will assume that to be yellow. Okay? We will assume that to be yellow, and that yellow can be taken as what is the average deviation that the color of light will. So this is the least amount of deviation that the color of light will follow. This is the maximum amount of deviation, and somewhere in the middle yellow applies. So yellow is on an average. On an average, what is the deviation that the colors are following? So what will be the average deviation defined as? That's delta y. And what was the formula for it for small angle I? For small I, it should be delta y is that's mu y minus 1 into a. I'm taking that to be the central color for now. Okay, I'm taking that. Central color, that means on an average, what is the deviation that each color will follow? That's delta y. I hope that mu y, do you understand why? Because that will correspond to some yellow color. This is how we define the average deviation. All the equations that I will give number, those are important equations, okay? This is how we define average deviation. The next term that will be important to us is called, let me keep on forgetting the name. It's called angular dispersion. Angular dispersion. What is angular dispersion? When the ray of light goes and hits this prism, then in some colors it comes out. Na? Then what is the angle for this spectrum? How much angle will it subtend? So what is this angle? This is that angle na? That I'm talking about. That's the angle between the two extreme colors. And how will I find the angle with the two extreme colors? That's delta V minus delta R. Yes or no? So what is angular dispersion then? That's defined to be delta V minus delta R. Do you understand? That's the angular width of the spectrum. You can even assume to be the angular width of spectrum. Okay? By the formula, if we go for small angles, then what is delta V? That's mu V minus 1 into A. What about delta R? Mu R minus 1 into A. I think some things cancel, and then what will you get? Mu V minus mu R into A. Is this correct? Please check. Is this correct? Mu V minus mu R into A. Are you writing with me? So, this is angular dispersion. Do you have any problem in the idea of average deviation and angular dispersion? These two things are important to us. Another important term which actually decides how powerful is your prism, is called the dispersive power. Dispersive power. And how is the dispersive power defined as? It's given to be omega, by the way. I will use the letter omega for it. And omega is defined as how much angular width can you give, and on an average, what is the angular deviation on an average? So it's something like this. Omega is defined to be delta V minus delta R by delta yellow. It's the ratio of the two things. The ratio of angular dispersion divided by average deviation. Okay? This is how we define the ratio. If I substitute the other forms, then what will I get? Then omega is also equal to mu v minus mu r into A divided by mu y minus 1 into A. And if I cancel A's, then what will I get? Mu v minus mu r upon mu y minus 1. That's omega. Some definitions that will be useful to us later. Do you understand the idea of why omega is defined the way it is defined? It's like how much angular width, how much you can do for a given prism, divided by what is the average angular dispersion.
Can you look at that dispersion power, like what angle that above diagram?
What is dispersive power in this diagram?
Angular dispersion.
Angular dispersion is basically the angular width of the spectrum. And what is that angular width? The extreme colors क्या है deviation. Either से extreme color is one of them is red, one of them is yellow, one of them is violet. Then what is this angle? That's delta V minus delta R. That gives the angular width of the spectrum. That's angular dispersion. Good. Is there any problem with the basic quantities? These are basic quantities that will be useful to us. Okay? Can I go forward? Great. Now I will talk about two things, very important cases. What if you have no average deviation, still you have a dispersion? And what if you have no dispersion but still there is an average deviation? So these are the cases. No average deviation and dispersion, and there is the case of dispersion with no average deviation. Let's try to understand it term by term. And for this, let me also define the setup that we will use. The setup will not be only one prism, you will use two prisms this time. So two prisms में आप देखो. Was that written? You have written up?
Yes.
The setup is something like this: that you have two prisms. One of the prism is this with an angle A. There's another prism which is like this with an angle A dash. Let's say here mu, here mu dash, and there's some medium which is in between them. Let's call it air. How will the ray of light pass? Let's say the ray of light is incident like this, goes like this, comes here like this, goes like this, comes out like this. Is there any problem with this? If you actually check, then there are two deviations that are occurring. A deviation due to the first prism, then there is a deviation due to the second prism. What do you think? Should I add the deviations or should I subtract the deviations? Think very carefully. Why subtract?
In different directions. They're deviating the light in different directions.
Here the deviation was something like this. Clockwise. What about this? Anti-clockwise. should subtract the deviations. Huh? So the deviations, the delta is given to be, let me write it here. That's delta 1 minus delta 2. Now what is the deviation that occurred due to the first prism? The formula is some very simple. Huh? Mu minus 1 into A, and delta 2 is mu dash minus 1 into A dash. So A and A dash need not be same in general, any kind of prisms. Then what will be delta? Mu minus 1 into A minus mu dash minus 1 into A dash. If we have a setup like this. Now we will do all the discussion for this setup only. And what will be the average deviation here? What will be the average deviation? What is average deviation defined to be? That's defined only for yellow color. No?
Yes.
Then what will I write? Delta yellow, that's equal to mu y minus 1 into A minus mu y dash minus 1 into A dash. This is the definition of average deviation. Is there any problem here? What about the angular dispersion? How will I find the angular dispersion? Batao. That's delta y, delta v minus delta r. What is delta v? Mu v minus 1 into A, or get minus mu v dash minus 1 into A dash minus mu r minus 1 into A plus mu r dash minus 1 into A dash. Are there some terms that cancel? Please check. I think I will get something like mu v minus mu r into A. This is the first term. First term is A cancels. What about the other term? I think A dash cancels. Huh? And then you will get something like mu v dash minus mu r dash into A dash. This is delta v minus delta r for this. So if you have two prisms which are connected in that fashion, then this is how you find the average deviation and this is how you find the angular dispersion. Is there any problem? Now let's come back to the heading. The heading was, what if there is no average deviation but there is a dispersion? So what if delta y equal to 0 but you have this form? Then what will you get? So please write with me now so that you don't get lost here. Should I wait some time? I think I am waiting 2 minutes. Right up until here, then we will go forward. We are taking a very specific discussion where two prisms are in contact like this. Assume there is air in between the two prisms.
why will you get that?
For all the colors, there will be some kind of deviation. It may happen, sir. No. The thing is this. See, when I say colors, those are not perfect lines. I don't have perfect violet. There's a light violet, dark violet, and all those things. There are shades of violets. So it may happen that one of the shades actually coincides with other shades. So there's a bit pure. Maybe some of the shades of indigo and violet coincide. Either I have to go like that doesn't mean they will not disperse. They actually are. They have some distance. It's your naked eye, you can't see it. But if you see through spectroscopy, you will be able to see it. Every color disperses or because their wavelengths are different. It's totally different. You can't see. Is it okay up until here? Let's talk about the case 1. What was the case 1? No average deviation. No average deviation meaning what? What is 0?
Del
y
V
is equal to
minus
0. Dispersion. Please remember, I have said no average deviation. I did not say no deviation at all. On an average, there is no deviation. But obviously, each individual color will follow some deviation. That's why there is dispersion. Dispersion, the meaning is that because there is deviation of different colors. Yes? If delta y equal to 0, then what is the condition that we find? Achha, I should have written something else here. Do you have some space here?
No.
Nahi hai? Card do. What was the definition of omega? This delta v minus delta r over delta y, and another form was mu v minus mu r over mu y minus 1. Yes or no? Then what was mu v minus mu r? That's equal to omega into mu y minus 1. Is it okay? Then can you see that mu v minus mu r can be written as omega mu y minus 1? Also here dash dash, so I should just put dash dash there. And what will I get then? Delta v minus delta r as omega a mu y minus 1 minus omega dash a dash mu y dash. So just a different formula, just some manipulations, but you should remember this as well. Is it okay? Now let's come back to the case that we were discussing. Case 1. No average deviation. Dispersion. What is this equal to? That's delta y is equal to 0. Is it okay? Delta y is equal to 0. If delta y equal to 0, do you remember the thing that we found? This is the equation. Then what will be equal to what? That means that mu y minus 1 into a is equal to mu y dash minus 1 into a dash. Yes or no? But if we have this condition, then what does the dispersion becomes? Look at this equation now. I think I can replace this dash dash with undashed thing.
Yes.
And what will I get then? Can I do it in one step?
Yes, sir.
I will get something like this. Please check. Please check if it is correct or not. If there is no average deviation, there will be a dispersion, and the dispersion will follow this formula. Okay? What was the second case? When there is no dispersion, but there was some average deviation. Okay? Then what will you get? Case 2. No dispersion meaning what? What is 0 this time? Delta V minus delta R is 0, not this time. There is no dispersion. Okay.
We have mu v minus 1 into a equal to mu v dash minus 1 into
Mu
a.
y.
Mu y minus 1 into a equal to mu y dash minus 1 into a over here. Or it will conclude mu y minus 1 equal to mu y dash minus 1. Like it need not be.
When did I say that?
We substitute those values to the equation.
Yeah. I substituted this thing as this.
So y
Is it okay? That's why I was asking, should I do it in one step? Should I do the whole thing? It's okay? What about the second equation? Now this term is equal to 0. Then what is the equation that we have? This one. The whole thing should be equal to this thing. Yes or no?
Yes.
Then what will I find? Omega A mu y minus 1 should be equal to omega dash A dash mu y dash minus 1. Okay? Now what will be the average deviation now? What should be the formula? Delta y was what? Delta y was mu y minus 1 into a minus mu y dash minus 1 into a dash. But now I can substitute mu y dash minus 1 into a dash as the whole thing divided by omega. Can you see? Just put it downwards, and this thing is basically this thing. Yes or no? And then I think I can take something common, and please check if my equation is correct or not. There is something like this should be delta by this thing. Is it correct? These terms, maybe the equations may look horrendous to you, but they are very simple to do even in your head. You can do the whole thing in your head in maybe less than 30 seconds. Don't worry, our discussion ends here. We will not talk about dispersion. This was the discussion that I wanted to do. Not more than this. So the main thing revolves around average deviation, dispersion, the angular dispersion, and dispersive power. Okay? That's the only three terms that you should be familiar with. Other than that, let me talk about some important points. Four or 5 points, and then we will start some problems. And the points are, I have been talking about A for up until now, na? A angle, I had an angle A, which I defined to be what?
Angle of prism.
R1 plus R2, na? I had this R1, this is R2, this was A. And A was defined to be R1 plus R2. What if you have a figure like this? And the ray of light comes here, goes and goes like this. And this is R1, this is R2. And this is A. What about R1 plus R2? What is it equal to now? It is equal to P this time. So can you see that whatever, so if this refracted light is sort of parallel to the base light, then the other angle will be your angle. You can even check by geometry that it happens. So V is equal to R1 plus R2. So please don't be stuck on one angle. Good. What if your R1 and R2 are equal? Achha, in what condition will the R1 and R2 be equal? In what condition?
I is equal to E. Again.
In what condition will R1 and R2 be equal? Come on, we talked about it yesterday.
Oh, no difference. No difference.
When incident ray is normal to the
Minimum deviation.
Huh?
Minimum deviation.
Minimum deviation. In the case of minimum deviation, you find R1 and R2 are equal because I is equal to E. Yes. Now I am not going to prove it, but you can prove it geometrically that if your R1 and R2 are equal, then you can claim that BC is actually parallel to DE.
Yes.
You can prove it geometrically that BC should be parallel to DE. When delta is delta mean R1 equal to R2 is equal to R0, that implies that this is this. Is it okay? PC is parallel to D. It's very simple proof, you can do it yourself. Okay? Please go for it. Number 3. What if your prism is cut out? What if your prism is given something like this? Some angle B, some angle C. How will you consider the whole thing again? You will assume as if the prism is whole. You will assume as if the prism is completed, and what will be this angle A? Should be 180 minus B plus C. Na? Yes, if B and C are mentioned, you will assume as if the whole prism is there. Okay. This is the third part. Everybody with me up until now?
Yes.
Have you written everything? Should I wait some time?
That's one.
Let me wait 1 minute and then I will go. If you feel like I'm going a little fast, then tell me. Not writing? Can I go on? कोई प्रॉब्लम नहीं है बस ये रेस जो है नहीं वैसे डायरेक्ट वो नहीं है बट रादर ये एंगल से ऊपर हो जाएगा उसको ये एंगल थोड़ा सा चेंज है बस ठीक है. What is the fourth point? A very interesting point. And let's say if you have a deviation something like this. Goes like this, but then comes out like this. Now what do you think ये angle A है, and let's say what will be this? This is the angle R2, this is the angle R1. What is the relation this time, R1 and R2? What do you think it should be? Should A is equal to R1 plus R2?
R1 minus R2.
R1 minus R2 they are saying, what?
Because one is going clockwise, another one is going.
Yes, very good. If you actually look at this, these are not, you can't just directly say this is the angle here. Arrow में लिखता नहीं हूँ, but this matters. With respect to normal, see how the angles are opposite. And previously, what was the case? When the rays were coming like this, then what was the normal? ऐसे. And how are the angles?
Same. Same direction.
What about this time?
Opposite.
So what should I write now? I should write A is equal to R1 minus R2. And now you may think, why will the ray come out like this? Do you remember that we did a question yesterday? The fourth question. How are the rays coming out? If you remember, the rays were ऐसे क्या? ऐसे आया, फिर ऐसे आ रहा था ना? Do you remember that? Was it following this fashion? And now if you want to go, you can go and check. You can check that this angle is actually something like 80 minus 30. One of the angles was 80 and this angle we found to be 30. Do you remember? And this angle was 50 actually. So 80 minus 30 is 50. Can you see? Follows this one. You can check our previous example and you will get that. Anyways. Yes? Please be mindful of the answer. Acha, let me ask you this. This is a very simple question to ask, but sometimes I do need to ask it. I have a vector like this, vector V vector. This is y-axis, x-axis. I'm going to make two arrows and then you tell me how do we find the angle. ऐसे या ऐसे?
Second.
ऐसे नीचे?
First one.
How many in favor of second one? How many in favor of first one? Do you understand? Angles are made with respect to an axis. That axis is not changing, you are changing. If I were to assume this, then it's all wrong. So we measure angles with respect to normal, na? That's why I made the angle like this. Please don't mix it up. Okay? And then you will say, okay, sir, ये भी तो ऊपर ही है. ऐसा नहीं होता. It's angles with respect to normals. Anyways, the fifth point and the last point is this, that if you have a structure like this, then what happens? And the ray of light enters, follows this, then follows this. You will consider this case to be again a prism. You will approximate. Let's say you know this angle. What is this angle by the way?
90.
That's 90. That's A. This will be R1, this will be R2. And you will consider this case to be again like a prism. And you will do the whole problem. Okay. Considering that the base can be taken down like this. The base doesn't really matter since in most of the questions we only care about this angle here. pink pouch. Barbie बनी थी उसके बाद नहीं पेपर है पाउच है ना वो तो अच्छा उसमें बार्बी क्यों बनी है और उसके सूट करता है उसके If you're done with the points, then we are done with the theory part of the ray optics. Now let's do some problems, and then we will be done with the chapter. Then we will start with something new from tomorrow onwards. It's called wave optics. Can I go on with the question? Let's write this question then. Start off with something easy. Here is the question. I am giving you 3 minutes, then I will start at 12:43. So we have plenty of time. Option C is incorrect. Anybody else? Still 1 minute left. A is correct. Can I start off with the question? Anybody else? Did you get it yourself or by the Don't help each other, idiots. Try to do it independently. Okay then. Here's my pen. You are given that the material has a refractive index this, and then some angle of deviation will be. They are asking that. Then the only formula which relates delta min and mu is what? The only formula. Mu is sine A plus delta min divided by 2 over sine A by 2. Yes or no?
Yes.
But this is given to be cot A by 2. But what is cot A by 2? That's
Cos A by 2.
cos A by 2 divided by sine A by 2. And then the denominators cancels. Then I think you will get something like sine A plus delta min by 2, which is equal to, can I write cos in terms of sine? Cos 90 plus theta, 90 minus theta, something like that. What can I write? Minus or plus? Should be minus. Sine of 90 minus A by 2. But then if sine of this and sine of that are equal, that means the angles are equal. So A plus delta min divided by 2 is equal to pi minus A divided by 2. And that cancels, and then you will get something like delta min is equal to pi minus. Very simple question. The only formula that relates the two is this. You just have to substitute and get the answer. Let's try something different. Can I give the next question? These are all simple questions. There's nothing challenging about them. Sirupa can keep writing, write very slowly. Let me write the options. you get the correct answer, you don't have to write the options. It's okay. Attempt. क्यों? One minute left. Should I start? Or do you want me to wait? एक आंसर दो. Start or wait? 2 minutes more. It's not that hard. You've done a similar question in this class. A very, very similar question. When we were talking about PIR. Then try to think. can I start with the question? I think I've waited long enough. Yes, sir. It's given that at some angle you enter, and your angle theta should be in such a way that you should pass through AC. What was the no emergence condition when it doesn't pass? When your angle of incidence, that means this R2. So let's talk about this. When this R2 is less than theta C, this is RE, this is R1, this is R2. If this R2 is less than theta C, then it will pass through it.
Yeah.
If your R2 is greater than theta C, then TIR will occur. So let's find this R2. So what is the condition? Condition of passing through RC, through AC, as R2 should be less than theta C. But what is theta C? Sine inverse of 1 by mu. Everyone knows this?
Yes.
That's R2. Now how to relate this? I want to find a relation between this. Achha, let me call this I to be theta. I want to relate this R2 with theta, but I have a relation between R2 and R1, then I will apply a Snell's law here. So पहले R2 and R1 में relation क्या है? A is equal to R2 plus R1. Then R2 is equal to A minus R1. But this R2 quantity is less than theta C, so that means this quantity is less than theta C. A minus R1 is less than theta C, which is basically sine inverse of 1 by mu. Okay? Achha, why did I write R2? It's okay. Now what will be R1? So R1 will be greater than actually A plus theta C. No, A minus theta C. Did I write it correctly? Please check. R1 should be greater than, let me erase this part so that it will be clear. R1 should be greater than A minus theta C.
Yes.
What will be sine of R1 then? So sine of R1 should be greater than sine of A minus theta C. Please remember that this inequality will only hold if your sine is in the 0 to 90 wala domain. Only in that domain it will hold. Okay. Now I have sine R1, I can relate with sine theta. By Snell's law, what will I get? By Snell's law, 1 into sine theta is equal to mu into sine of R1. Na? Yes? So that means theta is equal to sine inverse of mu sine R1. But sine for passing through condition, your sine R1 has to be greater than this. That means your theta has to be greater than sine inverse of mu sine R1. Achha, wait. This factor has to be greater, so sine inverse mu sine R1 has to be greater than sine inverse mu and then sine A. What is theta C? What is theta C? Minus sine inverse of 1 by mu. Do you get it? But what is this quantity equal to?
Theta.
That's theta. So that means theta has to be greater than this whole quantity. Does it make sense?
Yes.
Any options that matches? Option D matches maybe. Let me check if the option is correct or not. Okay, I have A minus.
Everything about minus.
But this is not so good. Let me check the options again. So, no, A minus is the correct answer. What are the options? Acha, there were some minus as well. There was a minus in the D option and a minus in the B option. Anybody got it? I think I did not write the correct options, that's why I'm not getting the. Anybody got this answer? At least I good. You got it? Very good. So this was the condition of passing through AC. A very simple question. If you remember, we have done exactly same question when we were discussing TIR. वहाँ पे भी बहुत सारे था. Let's try this question now. Can I write the question? So it's a very long question, so please write with me. So we will do this one first. I think the question is basically talking about the point that you raised. We have two prisms, it produces no dispersion. So I have to maybe give the diagrams as well. So, attempt the question. Okay. I will start with the discussion on 107. It's a direct question. Direct formula question. answer. Zero point
25.
Let me check this book. I don't think there is any need of it. That's correct. Anybody else? Come on, it's a direct formula question. What are you even thinking?
Yes, sir, 0.8.
Yes.
So it is 0.5.
Very good. Making some mistake, obviously.
Zero point 0.25.
0.25. Very good. Okay, then I'm starting with the question. I think this is a case of no dispersion and some deviation. No, no dispersion, some deviation. Then how to find the delta? I've given a direct formula. Delta is equal to mu y minus 1 a minus mu y dash minus 1 a dash. And now we just put it and get the answer. So 1.5 minus 1 into 6 degrees minus 1.55 minus 1 into 5 degrees. And you'll get 0.53 3 minus 0.55 into 5.
2.75.
0.75.
2.75.
2.75. So that will be 0.25 degrees. Yes, very simple. I don't know how he was getting 0.5. Either 2.75 or 2.5 लिख दिया था. Very good. Let's try this last question of the day. So इतने में ऐसा टाइम लगेगा. the answer. Don't tell me you have not written the question. Degrees. Again the question. This is again a fairly simple question. Achromatically combined meaning their mu's are different. Huh? So that means their wavelengths, the light will pass with different wavelengths. Or rather, different mu's. Different mu's. Wavelength is obviously going to be same levels. It's all formula based, you don't have to think a lot. We leave this question for now, we'll discuss it later. I did not have got achromatic addition. We'll discuss it in the next section. Okay? Leave it for now, we will try to take it as a homework. And this condition, this matters actually. Next lecture, it's only 10 minutes discussion, we will be done with this. Then we will start with something new called wave optics. Okay? For now, let me give you another homework question. Try to attempt that.